So now we have 6 molecules of water and we have 1 molecule of ethyl. So now we know uh, that a molecule contains. Uh, now we can actually write the total formula of a molecule, that is C2H5OH plus 6 molecules of H2O, right? Because we calculate the molecules of water as 6, therefore there will be 6 molecules of H2 and there will be 1 molecule of C2H5OH. We have, now you all can see that we have the mass, total mass of the sample, we have the formula, right? So now we can calculate the mass of individual atoms present in the sample. So we follow the same process. What we'll do, we have 2C, so 2 into C is 24. 24 by 153.3 into 100, 3.3 into 100, right? This will give us the mass of carbon. The next thing we have is H. Total H we have is H5, 6H and 12H. So we have 18H. 18H, 18 into 1 by 153.3, the total mass, 0.3 into 100, right? The next thing we have is O. We have 1 O and we have 6 O. In total we have 7 O. 7 into 16 by 153.3. 7 into 7 into 16 will be 112 by 153.3 into 100 into 100, right? So through this we'll calculate. Through this we'll know the percentage composition of individual compounds. Anyone has problem? Yeah, so I just confirmed the answer and it is correct. Means we I'm also getting 15.65. The method in the book is slightly different, but it's the same thing that we have done. They cal they calculated of separate, they calculated of C2H5 and water separate. We just mixed it. So our method is also short. I think it is more simple to understand, I should say. This is basic maths. Okay. Now the next thing we have is empirical formula. What is the empirical formula? The main thing that many students face problem is that what is the empirical formula? Empirical formula is the simplest formula that a compound can have. Let's suppose we have hydrogen peroxide, H2O2. To calculate the empirical formula, we just take out the most highest common factor in it. Empirical formula is the most simplest formula a compound can have. So let's suppose we have hydrogen peroxide, H2O2. Out of H2O2, we'll take out the most common factor. The most common factor is 2. We'll take out 2. The rest thing that is left out is known as empirical formula. So out of H2O2, we took out 2. Then what we have HNO. So HNO will be the empirical formula for H2O2. Similarly, we have glucose, C6H12O6. Out of C6H12O6, we'll take out the highest factor. Highest factor is 6. When we take out the highest factor, what we are left with, we are left with CH2O. So that is the empirical formula for glucose. Therefore, empirical formula is the simplest formula a compound can have. It That's all. So you all can also write the definition. That's not a great deal. It just gives the simplest ratio of in whole number of atoms of different elements present in one molecule of compound. Bookish language. Okay, so this type of question definitely comes, means many a times comes. I don't know definitely comes or not, but it comes that find the empirical formula of the compound with the following percentage. They give you like this, that a compound has this percentage of atoms of molecules. So we'll do part number B, right? So whenever such type of question comes, what you have to do, you have to create a chart. This creation of chart is a must. It helps you in solving your question. So this type of question definitely comes in your exam. Means many of time have come. Whenever such type of question comes, you have to basically create a chart. This type of table will help you solve the problem. So in the first column, we write the name of the element. So we have Mg, magnesium, sulfur, oxygen, water. In the next column, we write the percentage composition that we have, right? We write the percentage composition that we have. In the next column, we write the atomic mass of each atom. So of magnesium, it is 23, I suppose, or 24. 24 Mg 1224. Of sulfur, we have sulfur is 32. Yes, it's 1632. So for sulfur, we have 32. For oxygen, we have 16. And for water, we have 18. We write this in the next column. So we did that only. Yeah, you all can also see. In the first column, we wrote the name of the element. In the second, the percentage composition. In third, the molecular mass, the molecular weight, 18, 16, 32, 24 of that compound. And in the next, we calculate the ratio. What is the ratio? We know that out of the total, 9.7% is magnesium. So what we'll do? 9.7 by 24. 9 by 7 by 24. The percentage composition by atomic mass. Just remember the method. Percentage composition by atomic mass. 13.01 by 32, 26.0 by 16, 51.22 by 80. So like this, when we'll get a ratio 0.406, 0.406, 1.625 and 2.84. Now whenever you get the ratio of atoms, then you have to multiply by the highest out of these all. Means you have to actually take out the ratio. So how we'll do that? 0.406 is the smallest of all. You all are observing that 0.406 is smallest of all. So we'll divide all the ratio by 0.406. So 0.406 by 0.406, 0.406 by 0.406, 1.625 by 0.406, and 2.84 by 0.406. Okay, so many a times students have problem to actually simplify the ratio. That how can that 1.625 by 0.406 is a bit complex. 2.84 by 0.406 is a bit complex. So you don't have to solve it exactly. Here you have to do smart work instead of hard work. You have to just make a wild guess. See 1.6 and zero point 0.4. Just ignore the afterwards. You can do like this, that you can ignore the point after 2. So we have 1.62 and we have 0.4. We know that 0.4 into 4 will yield you 1.6, and therefore it will be 4. We know that 0.47 will give you 2.8. We ignore the decimal after 2. So after 2 it was 6, so we ignored it. And what we'll do, we'll just then think logically. 0.4 into 7 will give you 2.8, therefore it will be 2.8, right? So now we have these numbers, these simplest ratio number, therefore they are actually the contribution of that element in the empirical formula. The contribution of magnesium in empirical formula is 1. The contribution of sulfur is 1. The contribution of oxygen is 4. And the contribution of H2O, water, is 7. Therefore, our empirical formula will be Mg1. Mg1. If you don't write 1, then it's not a problem. Sulfur, oxygen, O4, and H2O7 and 7H2O. You can write that like this also, or you can also write that H2O7. Both are correct. Fine. Anyone has problem? Okay, so in the same kind of problem, we also get key. You have to calculate the molecular formula of the compound. So in these type of question, we first calculate what is the empirical formula of the compound, right? So we had a compound is first found to possess 40% of carbon, 6.7% of hydrogen, and 53.3% of oxygen. So what is the first step? To create the table. To create the table is the main step. In first step, we'll write the name of the element carbon. In the next, we write the percentage composition, right? Next, we write the percentage composition. The percentage composition of carbon is given 40, of hydrogen is given 6.7, and of oxygen is given 53.3, right? In the next column, we write the atomic mass. Atomic mass of carbon is C612, therefore it's 12. Of H is H11, therefore it's 1. And of O is OH16, therefore 60. And in the next, we divide the percentage composition by atomic mass. Percentage composition by atomic mass 40 by 12, 6.7 by 1, 53.33 by 16. Therefore, it will give 40 by 12 is 3.3, 6.7 by 1 is 6.7, and 53.33 by 16 is again 3.3, right? The next thing we do is we take out the smallest ratio and divide it by all. The smallest ratio is 3.3. We divide it by all. 3.3 by 3.3, 6.7 by 3.3, and 3.3 by 3.3. So now what we'll do, 3.3 by 3.3 is 1, 6.7 by 3.3 is 2, and 3.3 by 3.3 is 1, right? Now this will give us the empirical formula of the compound. So now what we'll have as the empirical formula of the compound? As the empirical formula, we have C, H2, and O. This is the empirical formula of the compound. Now we have that its molecular mass is 60. Okay. Now we came to know that what is the empirical formula? It is the formula that we made by taking out the highest factor out of the molecule. So if we multiply that highest factor again in the molecule, then it will reform the molecular formula. So we multiplied a number n into our empirical formula. So it will give out the molecular formula, and the weight of this is given as 60 in the question. So you can say its molecular mass is 60. So now what we'll do, we'll calculate the molecular mass of empirical formula. C is 12, so it will give out 12. H is 1, it will give out, H is H2, so it will give out 2, and O is 16, therefore it will give out 16. So 12 plus 16 is 28, and 28 plus 2 is 30. So what we have, n into 30 equals to 60. Therefore n will be equal to 2, right? If n will be equal to 2, then what will be a molecular formula? C2H4 and O2. This will be a molecular formula. So it followed the same step, but at the last, what do we took out the weight of the empirical formula, multiplied it by the factor that was initially took out from the molecular formula to form the empirical formula, and then we equated it to the molecular formula given in the question, molecular mass given in the question, and we found the value of n. N came out to be 2 in this case, and then we multiplied it into the empirical formula to get the molecular formula. Clear? Yeah, so here are two questions. The first question was asked in Icse 2015 paper. The empirical formula of two compounds is CH, and their vapor densities are 13 and 39 respectively. Find their molecular formula. So you have been given molecular mass, but in an indirect way. We saw that molecular mass is twice into vapor density, right? Now we have the vapor densities of both, because two compounds share the same empirical formula, but their molecular mass is different. One has the vapor density of 13. So in the first case, we have vapor density as 13. So vapor density equal to 13. Therefore, molecular mass will be twice into vapor density. That will be 26, right? In the second case, we have vapor density as 39. Therefore, molecular mass will be twice into vapor density. That will be 78, right? So these are two things. Now we have to calculate the molecular formula. We know that to calculate the molecular formula from the empirical formula, what we'll do, we multiply the empirical formula by n and then we equate it to the molecular mass. So CH, so we'll just write CH here. CH, this molecular mass of CH will be, C has the weight of 12, C612, and H of 1. So total will be 13, right? Now what we'll do, we n into 13 equal to 26 for the first case, and the factor which we initially took out from the molecular mass to make the empirical formula, n into 13 equal to 26, right? Therefore n will come out to be 2, and in the second case n into 13 equal to 78, n into 13 equal to 78, therefore n will come out to be 6. Okay, so to calculate the molecular formula, we multiply this n again by the empirical formula. So a molecular formula will come out to be C2H2 and C6H6, right? So this was the question that was asked in Icse 2015 paper. The next thing we have, the next question we have is on analysis. A substance was found to contain 54.454% of carbon, 9.09% of hydrogen, and 36.36% of oxygen. The vapor density of the substance is 44. So you have been given the molecular mass of the whole substance. So you have to calculate the empirical formula and then the molecular formula. So we right now saw two examples to calculate the empirical formula. What we do, we create a chart. Chart is a must. In the first column, we write the name of the compound, CHO. In the next, we write the percentage. So we have 54.44. My hand. In next, we have 9.00. Next, we have 9.09, and for oxygen we have 36.636, right? In the next step, we write the molecular mass of the compound, right? So molecular mass of carbon is 12, for hydrogen it's 1, and for oxygen it's 16, right? In the next step, we just divide the percentage by the mass given. So in the next time, what we'll do 54.44 divided by 12. We'll do 9.09 divided by 1. We'll do 36.66 divided by 16, right? So now we have to calculate this. 54.44 by 12. It will give a approx 12. 12 4 is 46. 4.5. It will give approx 4.5. This will give 9, and this will again give 16 to the 32. 16 to the is 32, and divided by 8. So it will give 2.3, 2.4 approx. 2.3, 2.4 like this. I'll calculate the exact. That 36.66 divided by 16 will give out 2.29. Yeah, 2.29. And 9.09, 54.44 by 12 will give out 4.53. So I was approximately correct. So the next step we have it. We take out the lowest ratio that we have. The lowest ratio that we have is 2.29. So we take that and divide it by the rest ratios. So 4.53 by 2.29, 9 by 2.29, and 2.29 by 2.29. So what we got, 4.43 by 2.29 will leave us to approx 1.5. It will leave us to approx 2. 4.43 divided by 2.29. Yeah, 2. 9 divided by 2.29 will leave us to approx 3. 3 is a 4. It will leave us to approx 4. 9 divided by 2.29, I'm just confirming. Yeah, it will leave us to approx 4. And 2.29 by 2.29 will leave us to 1. So now through this we know the empirical formula of the compound. Empirical formula of the compound will be C2H4 and O, right? This will be the empirical formula of the compound. So we solved the first part. The first part was to calculate the empirical formula of the compound, right? Now we have to calculate the molecular formula. To calculate the molecular formula, we have the vapor density. And now we also know that that molecular formula is twice that molecular weight equal to twice into vapor density, right? So what we'll do, we'll just use that formula, that molecular mass equal to twice into vapor density. The vapor density has been given as 44, so that will be 88. Now we have the molecular mass of the compound, and through the empirical formula we will calculate the empirical mass. Empirical mass will be of C2H4OH will be C is twice C, therefore it will be 2 into 12, the mass of carbon. H4 will be 4 into 1, that will be the mass of hydrogen, and O16, that will be 16. So the total mass will be 24 plus 20, that will be 44, right? Now what we'll do, we'll multiply n into 44 equal to 48, right? N was the factor that we initially took out from the molecular mass to form the empirical formula, right? So what we'll do n into 44 equal to 88, and will come out to be 2. And now we'll take this n and multiply by the empirical formula. So we'll have C4H8O2. This is the molecular formula of the compound. This is the answer. This and this are the answer.